Hello, everyone, and welcome to this webinar event. We're very glad to have you with us. My name is François Leclerc, and I am the product manager for Peel3D. I'm joined today by my colleague, Marie Simard, who is the Peel3D accelerator in charge of the USA. And we have the chance to have with us today our guest speaker, Mr. Jeff Garner. Jeff is a freelance 3D scan expert and a CAD specialist. So he's going to walk us through a valve cover project that he's worked on, as well as other very interesting projects that he's been involved with. Just before we get started, feel free to ask any questions through the question pane of your webinar interface. There will be a Q&A session at the end. And finally, I want to let you know there will be a recording available that will be sent to you directly after the event. So enough said, and Jeff, the audience is yours. Thank you.
Sweet. Hey everyone, my name is Jeff Gardner. I work out of my own freelance capabilities that I do a lot of mainly hot rod and interior or custom parts or anything of that nature. But basically, it's anyone that wants anything to do with CAD and scanning. It's kind of all the same. So, but again, my expertise is kind of classic cars and stuff like that. Yeah, the first project that I guess I can show you is that I have here in real time to kind of show the software is this valve cover. Just a couple features that I do want to kind of highlight that I really enjoy about the Peel software, which is probably the best part of the Peel package is the software. Like I've tried a lot of other scanners out there, and just the usability and functionality of the software that comes with your scanner is just, it's above and beyond any of the other products that I've ever tested out there, and I've tested quite a few. One of the best things and coolest things about it, in my opinion, is the ability to use targets. Now with Peel, you don't necessarily need targets. You can actually use geometry, but the targets actually have more than a function of just whenever you don't have geometry to use. They actually have the ability to scan stuff that you can't scan because they're already in place. For example, if I were to show this this cap right here, so I can scan this, I can scan it all together, and with this cap, I can then export this target matrix and then bring this cap, take it out completely and start scanning it, and it'll recognize that it's right here. Now this is probably a harder example because there's only 3 targets. You probably more or less want a minimum of 5 for it to be able to really catch onto the pattern, but I do have an example of what I mean. So if I were to come and scan this bottom, which I did, you can see that it has this this valve dam right here for the air, basically for a breather. Now I scanned it in this position, and then I was able to actually take the cover out, but I would leave these scan targets in. So that way, whenever I come to the valve portion, I can then just scan this all by itself and it show up in position exactly where it's supposed to be. So this can be used for if you were scanning a wheel on a car and you want it, or you're scanning the whole car but you needed as much data as possible. So you'd target up the wheel and the tire, and you target up the car. You would then export your target matrix and start a new scan. Then when you start a new scan, you import your targets. So it would be all the targets that you had for the full car. You can then take your wheel off, put it on the table, and start scanning it on the table, and it scans as if it's still on the car. So I do this a lot when I'm doing interiors. I would scan all the interior components that don't move, but when it comes to the doors, I can then scan the doors separately and then be able to get under the jambs, into the hinges, all around, basically just get way more data and have it be in place than if I were just to be scanning it normally. So we can kind of go through a project. We can start scanning this, and I can kind of show you my workflow of where I would where I would start. What we'll do is we'll start a new scan. And what I meant by importing the targets is you just come to import, and previously, like this would be my last one that I did with the air valve. If you see, oh no, it would probably be this one that has just all the targets in it. And I usually, I mean, scan by scan, I'll export these positioning targets as I go. This has basically all the targets that I have on the part back there, and then you just come to export, and you would export positioning targets. And you can see right here, I mean, as I went along, I have my different alignments, and then just my subsets of targets as I start collecting more and more targets, because I don't like to overwrite the files. Are really small file sizes, so I just like to kind of keep them in succession just for redundancy. But so when I come to the new scan, I will import the positioning targets, and I'll go with my latest. And so you see it brings in the targets. And even going a step further, if you were to bring, like say if you were to bring this top into the meshes, and you'd already gone through the process of reorienting and realigning and getting it so that it fits exactly where it's supposed to, you could then take this alignment and apply it to your scan, obviously, because right there, that's where it originally scanned was. And then you can export your targets again. And now all of your targets and everything of that nature is going to show up exactly in your predefined orientation. So that's basically a quick bypass of my workflow, but I'll kind of try to show you real time as best as possible. Yeah, so we have some new targets and or a new scan. So, and I hope you'll be able to see me hear me. My mic is stationary. But then I would come, import the targets, and hit scan. So yeah, so now we're ready to scan. So as you can see, is I have a valve cover right here. I have it on a turntable. This is good for small parts and little stuff like that. And I also have these, I think they're called paint pyramids, but they're little pyramids, and a lot of them over here too. I have targets on them so that they'll just be more reference data as you go. It gives you a small little point that you can raise your part up on, and it makes it easier for cleanup and just keeping it like off the ground so that it doesn't collect any of that data off the floor and try to just mesh it up around the edges and stuff like that. So this is a cool little trick and hack that I got on Amazon, just like this little paint pyramids. But again, so then you can see that I have my positioning targets. So then very easily can I come in and rescan any of these parts. There we go. And that lets you, the more and more that you use targets and bring these parts in, and the more and more data that you can get, the easier it is just to merge meshes together. So as you can see, the peel scans really quickly. I mean, this is a shiny part, it's painted. And it really has no problem. If you do have issues ever with it being shiny, which obviously this is, I mean, what this is doing is broadcasting a laser spectrum and measuring how fast it takes that light to come back, and that's how it measures. So obviously being shiny can refract a lot, and that's where you get kind of a lot of noise and stuff like that. So if you ever do have any issues with it being shiny or just not picking up, I recommend this. It's a scan spray. This is by a company called ASUB. They have about 3 or 4 different kinds, and they even have it where you can shoot it in a big gun for big projects. So it's not. If I was doing a whole car, it's a pneumatic gun that you pour the liquid in. It's just a pneumatic paint sprayer. But all it is a very light coating. It says it's just basically like a light dusting of very, very fine snow. And they've done testing on it to where, I mean, you cannot measure a difference between the scan spray. Does not affect the thickness of your part or anything like that. And the best part is that it sublimates, which means it dissipates over time. So I've used this on, I mean, $500,000 cars, and you're not going to have an issue. But it does severely increase, I mean, how well this scans. So it's not always needed, but it's definitely a tool that's always needed to have. Like you can see for that spout right there that I'm trying to pick up. It doesn't quite pick it up because for one, it's a different color. So you'd have to kind of sit and hover, and if you're on automatic shutter, I try to.
And what resolution are you scanning at, Jeff?
I believe I'm scanning at 0.5 millimeters.
Okay, that's
so
good.
I typically unless it's like a big broad side of a car or anything like that, anything with kind of small detail with all these holes and intricate data, I usually go for broke and go for the smallest resolution possible so that I can get the most data as possible. But as you can see, it's not quite getting this little spout right here. If I were to spray it, give it a little bit of love with the spray. You can see it picks it up a lot easier. And since I have automatic shutter on, I kind of want to sit and kind of let it hover over. Oops, sorry. And let it pick that up. But as you can see, it then began to start picking up that spout, which it's actually kind of a shiny metallic silver. So since I was on automatic shutter, if I were to let it kind of hover around more, it would eventually pick up all that. And then from here, let's go ahead and stop. And it's going to take a second to update, but I'll kind of show you my cleaning process of where I go from here.
Yeah, when we're in preview mode, it always looks a bit blurry, you know.
Mm-hmm.
But don't worry, everyone, it will clean up better than that.
Yeah, it'll just take a second. I got a lot of resources going on my computer right now with the scanning, the webcast, and a few other files that I have ready and open. Yeah, typically on my computer, I will tell you, one practice that I do like to do is having just a fresh state of the computer. I try to have as minimal as services running as possible. I try to fresh restart, obviously, to keep it going. I'll even turn off the internet, and I have a few other programs that I use to basically limit the services of my computer, because I want this thing to be running as smoothly and as efficiently as possible and not be waiting around. And I don't need to be checking my Facebook or anything like that while this is all going. Just the quicker I can make my computer, the more dedicated I can give it to the software, just the snappier it's going to be. And I can tell you, I mean, I used a fair amount of a lot of scanners, and it's the Peel software is just it's definitely, I mean, as snappy as they come. Like it's very impressive of how much data is actually in all of this. But so as you can see with the triangles, since there's a point, and I didn't quite get under there too much because I'm really focusing on scanning the top, then that makes cleaning up a lot easier. So I can just come up to connect and basically grab all the important stuff that I need. And I don't need any of this down here from the table or anything like that. And I can just go and keep only. And that's going to run and just delete all that table. Apparently part of the cap that I have on there looks like, but that's not a big deal. But yeah, that's the big benefit right there to those little pyramids. Because I mean, if it was just sitting on this turntable or on the table, then I have to start really getting in close and trimming away like all around here. And I will tell you too, if you do have holes and fine details, and I'm doing this just for the sake of it being a little quicker, but you can optimize your scan mesh and optimize accuracy of boundaries, and you'll get a lot more accurate boundary data as it goes. So yeah, so here's that scan. Just, I mean, in the 5 minutes or so that I was showing you, I mean, I have a really good, I mean, base already. And I mean, if I were to take that and say I've scanned the top already before, it's just more and more data that you can eventually merge together and really make sure that, I mean, you've captured everything. So then you can start showing in the bottom, and you can see that multiple arrays of data, and you merge that, you can see that I'll have just about everything on top of this part that I could ever need. And like I said, if I were to have the optimized accuracy of boundaries, which it just takes a little bit longer, and I don't want to just be sitting here watching this thing load, you would have, I mean, very, very accurate data to bring in. So I actually have a different software than the Peel for being able to manipulate the mesh and stuff like that. This is the Peel software right now. It's on a demo license that it's not giving me all the tools up here. So I'm going to switch over to that real quick, and it'll give me all the tools that the Peel software does have. So
Jeff, basically we'll be using a VX model from CareerFarm. It's the equivalent of our Peel to CAD. There are a few differences, but most tools and principles, ideas are the same.
Yeah, it's mostly user interface differences. I haven't noticed, and maybe you can tell me, Marie, if what they are, but I haven't noticed any of the tools being different. More or less, just kind of the layout of the process of scanning with my Spark is just a little bit different than scanning with the Peel. But when it comes to the tools and all that stuff, I haven't noticed. There's no difference in the capabilities. So we'll open this up, and like I said, all the tools are the same over here and as the Peel. So yeah, the first thing that I would do in cleaning this up would be to come to clean mesh, and I'll even lower the parameters. And I typically don't go with like the automatic isolated patches. I'll do it on one, which picks up, I mean, very, very little, just because I like to choose myself what data it deletes rather than it just be kind of automatic. I will do it for the max hole size. You do have to be careful, especially with working with parts that have holes in them that you need to take advantage of. I typically leave that around 30 or so, but you can always kind of ramp it up, and whenever you preview, you'll see like all the yellow around are all the holes that it's going to fill automatically. So like I said, you just want to be wary of making sure that you're not filling in any holes that you don't want. And then for the spike level, I typically like to ramp that up and kind of get a lot of the noise kind of reduced a little bit. That'll be my first process, and let that run and kind kind of take care of all that, any kind of creased edges or intersections or anything like that, and just kind of cleans it up a little bit, gets a lot of that dirty data out of there. That would be my first step. And then I would kind of come over here and click this little widget here on the bottom, and this gives you a lot more options of viewing. And so one trick of this that I didn't realize was there for a while was clip view. And this comes in handy in scanning too, especially for me whenever I'm doing interiors, because when I'm doing interiors of cars, like say I've basically scanned the entirety of the car and I realize I don't have some data over there on the kick panel. But whenever I try to scan the kick panel, it will it just basically shows me the back end of the cab and I can't see where I'm scanning. So what you actually can do in that case is it basically orients to the projection of your screen, and you can clip view, and it just slices right through. So if I was looking at that kick panel, like say the kick panel was over here and I'm like all the cab was right here, I would be looking at it in whatever angle I want to and just hide all that data, and now I can start scanning the kick panel or whatever you need. But I actually didn't know that was a feature for, and you can do it the opposite as well, but I didn't know that was a feature for a while, because honestly I didn't know this little toolbar down here was down here, and you can access this even when inside of your tools. So that can become really handy for whenever you need to get into those hard to see places. But you also have your viewing options here too. So sometimes I like to come in here to be able to see how the triangles reacted and how the mesh is working on it, especially when it comes to decimating and stuff like that. It gives me kind of a nice visual cue of just how clumped the data is. Typically, I will go through a few more steps similar to like smoothing mesh. So I'm usually not afraid to put the smoothing weight, I mean, pretty close to top, and I'll kind of run through a few iterations of it to make sure nothing is gets distorted too much. Another thing that I like to do that I didn't do in this case because I've already done it is whenever I bring this into from the peel scan to the peel model, I'll usually take that first scan and like basically not touch it, and then what I'll do is just duplicate that, and then that way this just gives me a master of all the data. That way, and just in case I delete anything, it's just a backup basically, and it's actually a redundant backup because all the original data is up here in the scan. But what I'll typically do on that first master, and I would typically name it master as I go. What I would typically do is probably just do that first initial clean mesh, just so that it just gets rid of a lot of the noise, and I'll get rid of all the basic stuff, but I don't want to start manipulating the mesh on it until after I duplicate it. So it just, and that way it also, like, especially when it comes into like smoothing. So let's go ahead and smooth this out. And like I said, I'm typically not afraid to run that up. And typically I'll do preserve boundary. I'll play with that, all depending on how well my all my openings are. So I'll play with that, and if it's a really crucial part, then I'll keep it pretty minimum. But if I know that it could use a little bit of love, I'll probably iterate that up to 0.2 or even 0.3 sometimes. And you can see once I apply it, it really takes a lot of that noise out. Even at 0.1, it really ends up just generally smoothing it all out. But I'll typically go in between 0.2 and 0.3, especially on outsides of cars. You'll get a really nice mesh in that fashion. And then as you can see, this is why I like having the masters, so that I can kind of toggle and make sure nothing's like severely changed out of whack or anything like that. I mean, it's not going to move stuff around so much as to where it's not, where you're losing data. I mean, it's just a really good tool. Another tip with your targets, when you're placing them, you kind of want to keep them away from edges, because if you can think about it, whenever you're scanning, it actually doesn't get the data of the target. It puts that target there, and then whenever you finalize it, or whenever you end the scan, it will fill those target holes. And as you can see, like right here, I have this target, and I can actually bring over. This target right here is just a little too close to that edge to where whenever it was scanning, let's see, I go to top 2. Oh, I can show you right here. So if I were to turn these targets off, oh, it's already done it. Typically, if you're still in the scan, you'll be able to just see a hole. And so basically, you just want to kind of keep those away from edges. You don't want to wrap these targets around corners or anything like that. You just want to keep them. I mean, the best practice is to try to find nice flat spots. So that's kind of why I avoided like this area right here, because this kind of has kind of a roll to it. You can put them on there. It's not going to be the end of the world by any means, but since this had so many flat surfaces, that's typically what I would go after. So that's why that did that right there, is just because I had that target just a little too close, and whenever it filled the hole automatically, which you can actually turn that feature off too, if that becomes a problem, you can actually turn the fill targets automatically, and basically do it yourself with the power of the fill hole tool, or bridge it with the fill hole tool and stuff like that. So you'll get a little bit more control that way. And 2, if it's just one, and you could have, if it's a full car, I could have, a whole box and a half of targets. I could have 750 targets. I'm not going to want to fill all those in individually. So I could actually come up into the scan again and bring that piece in as another file and chop away everything, and basically just give me that little section of where that hole is that I'm avoiding, and fill that in manually and merge that with the previous scan. And that way you don't have to do, the entirety of the scan. Like the ability to, copy and paste these models so quickly it's invaluable. Whenever I'm done with cleaning up a scan, I'll have copies on copies on copies of in here, because I'll take this and duplicate it, and now I can very easily just come in here and just work on a very, very small area, because maybe this hole right here is all I need for inside SolidWorks or anything like that. Very powerful with just being able to just go and delete and work on just the one section that you need, and not have to slow your whole computer down with trying to work on just one little section. And since it's just a duplicate, I still have all the data, no problem. So yeah, so I'd run smooth. And then once I get to kind of this point, we can start working on maybe merging these together. So I want this to be merged without the air valve, because I want the original part. I did need to scan it with the air valve in place so that I could position it whenever I scanned it. But I'm not going to use this part to be joined in with the scan. That way I can very easily toggle it on and off. But as you can see, if I did it without the air valve, I did miss some area right over here. Nope, this one. So I did miss some of this area over here, but I did get it when I scanned it with it. So what I'm going to do here is duplicate that. So what I'm going to do is take this duplicate, and I would chop
Hey Jeff,
all the area.
we have
Yes,
someone asking, do you use the shell function rather than scanning inside, outside?
I typically would use shell in my CAD software personally. I haven't used it too much in this software. I haven't had the circumstance of where that would be beneficial to more. I would rather have, I mean, since this is obviously this has been shelled, but there's a lot of, I mean, different thicknesses to the walls and stuff like that. So I wouldn't quite trust taking this and just shelling it inward and thinking that that was as accurate as being able to scan the inside. Plus, in my case for this project, the outside doesn't really matter to me because I'm making custom. This project is I'm making custom valve covers for this. This is a Hemi Dodge Charger valve cover. And what I really needed was the interior being accurate. And so this is the part that's important to me because I want to have the same volumetric accuracy. Basically, I want to have this be the interior of the valve covers I make, but then on the outside, I can make it whatever I want inside of CAD. So if I couldn't get the shell to work in my CAD software, that's when I would personally go to maybe trying to use it inside of this. And that's just me. That's just me personally. That's just my workflow. I don't typically use a whole lot of the edit functions inside. Like the only ones that I kind of use are maybe I will use offset mesh. I have used that before. So offset mesh I've used to basically, I would offset, it's a lot quicker and easier to offset the mesh than it would be certain surfaces, especially in SolidWorks. SolidWorks is kind of gives you, it's kind of a clunky software somewhat for scan data and for some of the surfaces that I bring in. So basically I would chop that area out and merge those all together, and it's just going to give me a nice clean scan. And then once I do that, then I can start creating a plane on the bottom, and then I would basically I created a plane from the circles inside of here and did it perpendicular to the bottom, and then did a perpendicular plane off of this, and then you can tell it inside of manual alignment which entity you want to be what axes, basically. And then boom, now you have it all nice and clean and aligned. And I align it towards my my gumball of how I have it in SolidWorks, so that whenever I go to front, it goes to front. Whenever I go to right, it goes to right. And it's uniform coordinate system along all the programs. So yeah, I realized that I've been talking for probably a little bit longer than I was supposed to. So
no, that's perfect.
Yeah.
A quick question. So like for the cover project, the one we're discussing now, would you send the whole interior or inside of the cover mesh to SolidWorks, or would you export like the silhouette or some cross section? What would you be using in SolidWorks?
That's a good question. So basically, to send it to SolidWorks or any CAD program really, the last step of my workflow would be to decimate. And again, I would take like this last cleaned up version right here, and I don't know if I've done it. Yeah, so I haven't decimated yet. So I would basically create a duplicate, and this one I would call decimated, just so I had the redundant version of it. I would decimate this because this part right here already has 2 million triangles. So I'd probably try to get that down to, I mean, maybe 500,000 or so. That way SolidWorks runs a little bit more efficiently. But I only bring into SolidWorks what I need, because the more and more, I mean, dense data that you bring in, the more and more it's just going to be kind of, you get any kind of lag. So I can probably show, probably on this project right here, to where I'm building a spoiler. I have the full scan, which is highly decimated because this is just for cosmetic appeal. And then if I needed richer data, I would really subtract what I needed. So actually I have a better example with this cab project, to where I have the full big decimated scan of the interior, but I also really needed this area to be really accurate. So I brought that in separately, these kick panels, in a little bit higher, denser fashion, and then created surfaces off of those.
Hey Jeff, what environment have you found that works well for scanning, or one that does not work well? Example, hard light outside, dimly light indoor lighting, or brightly lit area indoors?
So I've noticed that you definitely indoors is more preferred. If you're outside with a lot of sunlight, I mean, just blaring down, it is going to be a little bit more difficult to get that scan. So yeah, I prefer indoors as much as possible. I even have a canopy from Walmart that I'll bring out just to kind of give me a little bit of shade. I've had issues in the past where I was scanning a car and it was in the shade, but it was through, like, it was outside and had like some trees blocking the light. So like the different shade patterns were just causing irregularities of the shutter speed, basically. And so it was picking them up irregularly. So yeah, if you can have the most uniform, somewhat, I mean, just not blaring sunlight on it, like scanning a white boat out in the middle of the sun is probably, you're probably going to have a little bit of difficulty doing. And so yeah, indoors, I mean, you can scan easily in the dark because it has its own light. I've done that sometimes, to where, I mean, if I am getting weird glares or anything like that, I'll just turn all the lights off. And that's probably, I mean, I would guess that that's probably the best environment would maybe be in the dark. I don't know the science behind that or anything or anything that, but yeah, that's what I would recommend.
And then I had some. Yep.
And sorry. Someone asked me some questions of, do I need Wi-Fi access while scanning, or can I literally be off grid besides electricity and be scanning? No, yeah, you can absolutely be scanning off of no internet. There's no internet required for scanning, by all means. I do that all the time. Can you scan on a laptop, save the scan, then transfer over to a desktop to close holes, smooth scans, or does it all have to be done on the laptop you scanned on? You can absolutely work off a desktop as long as this meets the minimum requirements, or hopefully if you're going to a desktop, it has better requirements. The faster the computer, the faster your workflow. I use Dropbox personally, so basically whenever I scan something, I'll just hook my computer up to the internet, and that backs everything up, and then I can go at home or at my other office. I can open up my desktop and work off of that simultaneously, so that it just keeps a constant database of my project files.
That's good. You guys, any further questions? Last call for questions. We have 5 minutes left. But yeah, about scanning outside, maybe if I can add something, this is another field of application completely, but we have lots of customers doing building restorations. And as long as it's a cloudy day or that you're able to create some sort of minimal shade, you're good to go. So, but I'm assuming, Jeff, you scan mostly in garages, shops, so inside.
Yeah, I try to. I'm a big boy too. I don't like to sweat, so I'm down here in South Florida, so that's a very easy. That's very easy to do outside. But yeah, I mean, the beauty of it is that I can go anywhere and then scan your project, and then also at the end of the day, I can be anywhere to work on my project. So I have instances coming up where I'm going to be going out to California to scan a car, to work with a shop where it was built in Texas. It's going to be, the work is going to get done inside of a shop in California. And if I plan on taking a trip to Italy, I can continue my work, and I don't need to be right there with them. And it's going to be a very fun collaborative project that is that's for SEMA actually coming up. So it's really opened up a lot of resources that I previously just wouldn't be able to do. I wouldn't be able to, I mean, 10 years ago, or even 5 years ago, I wouldn't be able to just go to a shop in California and design their interior without actually physically being there. So now with the power, I don't have it here with me, but the Pelican case, it's carry on. I can keep it nice and close to me. I don't have to worry about the people, shoving it underneath. And you're free to go anywhere, scan anything. And it just, the options with 3D scanning it's just endless. It's being utilized in dentistry. In health. Creating prosthetic legs. It's anything. It's really, really, really powerful of how much broader the capabilities of what I can do to just expand my skill set. It goes way beyond doing hot rods and interiors. Are my niche and what I know. But if someone needed a cast or something made of their arm, I can easily scan their arm, create a surface of the arm, offset it a little bit, throw some holes in it, and I'll send it right over to the 3D printer. And within a day's worth of workflow, you can have a product that can be prototyped and be working on. So it's once I got into scanning, it blew my world wide open. And I have so many ideas, and I wish there was 10 of me. I wish I could 3D scan myself and duplicate it. And but no, it's working with Creaform and Peel has been one of the biggest game changers in my abilities. I can definitely say that.
It's nice to hear. We have someone asking, what program instead of SolidWorks do you use or recommend?
When it comes to STLs, I haven't personally used Blender. I know Blender is a free program that is a mesh manipulator. I know that I've heard of people using that. I personally have dabbled in Rhino, and I really like how lightweight. That is what Rhino does is surfacing and mesh. And my background is SolidWorks, and so that's kind of where my comfort zone is. But I am on the learning curve right now of learning Rhino, just because of their very quickly where SolidWorks bogs, Rhino is. It is fast. It is a very, very lightweight. It's not a constraints-based CAD program, so that's kind of the problem with SolidWorks sometimes is you'll design this whole thing and you'll get so far, and then you want to kind of tweak this little area, but that little area that you tweak is dependent upon up the line of the tree, so it'll just kind of blow up your model. Where Rhino is, I mean, once after you manipulate the part, it doesn't matter what you've done before or after. You can really go in there. It's a lot more design oriented, and with the power of the sub-D integration with it, to where you can take this scan and very, very quickly turn it into a sub-D and then or a NURB surface, then I mean very, very quickly, and then right away you already have a file that's I mean ready for 3D printing, that if you turn it into NURBS, ready for CNC work, and it's very, very fast. It's just a totally different way of thinking about CAD, so it's quite the learning curve. But if I were to start, if I were a real flowy designer of sorts, which is kind of where I want to be, I would recommend Rhino personally. And there's an array of other programs out there. I mean, you can use Fusion, you can use, I mean, basically any CAD program that can work with, I mean, that can import STLs, or at least surfaces or IGES or any sorts of like that would work. But yeah, that's my short, long answer.
No, that's good. Anyone else has questions? Is there anything any topic or type of projects that you'd like for us to cover next time?
And also too, I mean, if there's a way to share, I mean, any of my contact information, if anyone wants to, I mean, reach out and has any kind of more specific questions, I definitely open that up. We can sit down, have a little time and do a screen share, or just anything like that, anything to basically help and promote. So I don't know if there's a way to, I guess I can probably put it in chat, put my,
that's perfect.
Info.
Yeah.
Okay.
Thank you so much. One last question. So when you design a car, Jeff, what error range do you have or want to have?
What error range?
Yeah, so
like the tolerance, is that kind of?
I think so.
I mean, typically I like to have, I mean, as close to zero tolerance as possible. I mean, when it comes to doing interiors, I mean, basically everything is gonna get, I mean, the way that I know about, everything is gonna get kind of packed with Bondo just to really seal up that deal. So as long as everything's within, I mean, an 1/8 or a 1/16 of an inch, I'm pretty happy. It's not very precise. You're not working on a turbine engine or anything like that that needs to be, I mean, within a 100 thousandths or anything like that. But yeah, as long as it's within, I mean, a 1/16 of an inch, I mean, I'd be happy with it in the outcome. But I like to keep my tolerances as low as possible. If that was the question, I hope that.
Yeah. So the accuracy on the Peel 2, the one that Jeff just demoed, is 0.1 millimeter accuracy. So in inches, let me see, sorry. So 0.004 inches. So that's the tolerance, the accuracy. But there's also the resolution. So that's more of the finest details you'll be able to grasp. So this one, of course, with the Peel 2, there's a limitation we saw earlier on smaller holes. So 2 options: you can crank down the resolution on the Peel and spend a bit more time. You can roll up little piece of paper in your holes to be able to select like cylinders more clearly. And then of course you have the Peel 2S for more details. That's another scanner, smaller field of view, but better level of details.
So this is when I really need to be accurate with hole sizes. This is a kit off of Amazon. You can get the Scarrett kit, which is a lot more expensive, be certified, but these are all increments of 0.001 inches from 0.061 to 0.25, and they're just little pins. And they're all, I can stick these in the holes of what size they are and scan that, and it'll actually give me a nice perfect cylinder going into that hole. And I've found that that's a lot that's a very accurate way of getting those holes right where they need to be, because sometimes the scan will look kind of janky around if you don't spend enough time on it. So if you have a nice cylinder, that's gonna be a really easy thing for it to pick up and very accurate for finding the center of the positioning and projection of that hole. So
that's good.
That's a good kit to have on hand.
Good tip. Any other questions? Maybe we have time for one more. Jeff, I'll let you put your contact info and your code. Maybe you guys, you have a 5% discount code from attending this webinar if you want to apply it on accessories or a scanner. So you just have to give, when you get in contact with us, you just need to give us the code that Jeff is going to send to you via the chat.
So the code is just JG3D. I can give you my email at info@thejg3d.com. Feel free to reach me out. You can find me on Instagram. You can message me there at @the_JG3D. I'm compiling a lot of footage right now and going through it to turn into videos, but I'm trying to have a bit of a series on YouTube that will come out here shortly that will just kind of help explain quick tips and my workflow, trying to be more entertaining than most kind of tutorials out there. So you can look out for that. I got a lot of footage that I need to really compile into a more a precision end product. But yeah, you can Instagram, YouTube, email me, use code JG3D at checkout for your peel, and I'll be happy to help anyone that needs any help.
Cool. Hold on just one sec. Perfect. Hey, thank you so much, Jeff, for your time. It was super interesting, and thank you to all of you for attending. It's always nice to have your questions, etc. So please don't hesitate to either text us on Instagram or send an email to us if you have an idea about a webinar that you'd like to see on a specific topic related to automotive, and Jeff and I will sit together and try to find an interesting project to cover that. So thanks. We're all set.
Thank you all.
Thank you, Jeff.
I appreciate it.
Bye.
Absolutely. Take care.
Cheers.